Hello, it's Rick D'Amato with Roofing Contractor Magazine. We're on the work site of Mr. Bennett Hutchinson's new home on the Chattahoochee River in Atlanta, Georgia. Speaking today with Geoff Stone of Metal Forming Incorporated. Geoff Stone is owner of Metal Forming and is going to show us this Schleback Quadro Synco system, and I'll let Geoff explain the story to you.
Good morning, sir.
All right, Geoff, tell us what we got here.
This is the first leg of something that Metal Forming has been working on for quite some time called computer integrated roof manufacturing. The entire idea behind computer integrated roof manufacturing, as we call it, CIRM, is that in the not too distant future we want to be able to take the original 3D drawing of a roof. We want to change the as-drawn dimensions of that roof to the real as-built dimensions through digital documentation of the real measurements, feed it back into the software, feed the software into machines of all kinds to digitally fabricate a roof from the original drawing. This is the first leg of it. It's now working in the way we've just described it to you. We can start with a 3D drawing that's done in top view estimation software. We can, of course, you can do the automated estimation with it, and if you win the job, you can measure the actual dimensions of the roof, feed it back into the software, change the as-drawn to the as-built. Then you can download it to this machine control via the USB port, and we're now capable of fabricating a completely finished roof. By that I mean all notched for the eaves edge, and all notched and cut for all the hips and valleys and angles automatically through the machine control. There are lots and lots of advantages of that technology. The first and foremost obvious one is that on a typical architecturally cut up roof you can be reducing your labor costs for installation as much as 25 to 27%. That's a big, big savings. And really it's the first ever automation of that process through machine control and computer control. But there are many other advantages. There are potential advantages to digitally measure the roof even from the ground, so that we don't have to have personnel up on the roof tied off, measuring every little bit and piece, doing everything by hand, writing down everything by hand, making errors and the like. We can eliminate any kind of errors related to how to produce the roof. In terms of doing it digitally and accurately, that's very, very easy to do. We can eliminate lots of hand work, and so it's all about automating the production of roof panels. The machine begins with, of course, you have a decoiler to decoil the metal, and it goes into this device. This device is a notching system. It pre-notches the panel. The size of the notch is completely variable by the software according to the angle of whether the angle is very sharp or not so sharp, or you can set in the computer valley offsets and so on. You can set the size of the notches based on the profile, the length of the material, and how much material movement you want, thermal movement. So it's very, very, very flexible. So after it notches twice. It notches parallel for the eaves fall. Then it notches on one side or the other based on whatever the appropriate angle is. And then the material feeds through the machine.
Can we get under the hood, Geoff?
It's a portable roll former.
Can we get under the hood just to take a quick look?
High water now. Next flood. Coming big.
It's all married onto the Quadro portable roll former. We've been selling these in America for a very, very long time. They're rather famous for how easy you change profiles and so on by rotating or pulling cassettes in and out. And so you could say it's a portable roll former. It's not like most other portable roll formers, but it operates as a portable roll former.
So
in here right now is this particular job that we're doing today for Bennett Hutchinson Tip-Top Roofing is a 1 3/4 inch structural snap block panel.
okay.
So it's just the panel he chose. You can put as many as 12 different profiles in the machine.
12.
This particular one is a 1.75 inch structural snap.
Okay, thank you.
So after the roll forming takes place in the machine, it comes into this device. This is another computer device connected to the main control. This is basically an information station that tells the operator, I'm doing this or I'm doing that, or I want you to cut this angle and so on. And down here we have a post-cutting device, and this device rotates to whatever the proper angle is for the angle cut, and then goes back to the straight cut station. And there's a pre-developed stops in here, so you can just swing back and forth and back and forth. You don't have to look at it every time.
And that is machine actuated. It's not manual.
No, this is manual.
This is manual.
You see the shearing device here.
Right.
We do have a CNC device for this.
Okay.
That means computer numerically controlled device.
Right.
Most people who use this technology on an on-site basis would not buy that, because the fact is this thing makes panels so fast relative to the speed you can put them up there that automating that, or the cost of automating that for a job site machine, is really not worth it.
Okay.
We do have customers, implant customers, who do this technology. They're the ones who look for CNC on all that. In other words, from directly data from the control, it'll swing back and forth all by itself to the appropriate angle. But you won't see that used. I don't think people will do that on site. I don't think that the cost is worth the additional savings, because it's very fast and easy to do manually.
But the person running it manually, this device is telling that person.
He's telling him what angle he's cutting.
Here's where you're cutting it.
Set and so on. Yeah.
Okay.
This information screen here tells him all that stuff.
Okay.
We're going to run the machine for you in a minute. I didn't want to try and run and talk over the generator noise, so.
Yeah, the aerial devices are bad enough.
Yeah. So you'll see that in just a minute when Dale runs the panels for you, so you can see what we're talking about. So the real idea here, the real value, is to begin with digital data, digital drawing of a roof, to use that data to digitally fabricate a roof. This is not new in the sense that this kind of computer integrated manufacturing has been going on worldwide for 40 years, and most industries embraced it long ago. It's been unknown in our industry, and we're bringing the technology now to the roofing industry, because very, very little has really been done to help roofing contractors improve the productivity of their workers on a job site. And this device will do that in a very, very significant way. And that really is the story of computer integrated roof manufacturing. It's not, by the way, the end of the story. We are currently working very hard on digital measurement devices to even more rapidly and accurately give the machine the as-built documentation. We're working on the ability to use that same documentation to feed information to shears and breaks for all of the trim, cutting, and forming and so on. We're working to coordinate all of the machines internally to a sheet metal shop, back to the sheet metal shop's main computer, so they can follow jobs through the process and so on. So there's lots and lots of things we're doing with computer integrated manufacturing. This is the first one that's now in the market, has been in the market for about a year now, and there are many of them out operating very, very, very well, and we're real pleased with it. And the customers do feedback to us that they're getting anywhere from a 25 to 27% reduction in their labor costs for installing an architecturally cut out roof. We think that's a big deal.
That's pretty impressive.
Okay.
All right. Thanks, Geoff.